Good evening. My passion is to make malaria history through vaccination. As a research community, we know that humans can acquire immunity to malaria. They can become resistant. We also know that antibodies taken from malaria-resistant adults can be used to treat patients admitted with malaria. My research aims to identify the exact antibodies that make the magic of malaria immunity come alive. So we innovated. We had a few challenges to solve. First, the malaria parasite is big. Its genome encodes over 5,000 proteins. How could we decipher which proteins were the targets of the antibodies that could be used to treat malaria? Second, scale. How could we do a study that was sufficiently large, inexpensive, but allowed us to tackle the question robustly? I had read many papers, a study here, a study there, different design, different location, no scale, no consistency. Third, variation. Is malaria in Mali equal to malaria in Malawi? We know that the parasites are different. It's likely that the immune response would also be different. And finally, speed. We wanted to work fast, cost-effectively, and be prudent with our use of finite human samples of plasma. So we began with the merozoite stage of the parasite. This is the stage of the infection that makes you feel sick as a dog. You remember I told you that you could take antibodies from one person and use them to treat another? This is also the stage where those antibodies were shown to work. My slides aren't advancing. There they go. So we made the proteins in the lab. We synthesized them systematically in a very standardized fashion, and we printed them onto our chip, kill chip, a first of its kind in Africa. Each dot represents a malaria protein, and it literally lights up when antibodies bind to it. Now we could work fast, economically, and we needed less than a drop of blood. We love it. In parallel, I founded SMART, a network of African research leaders who share samples and metadata from human studies of malaria across Africa. We assembled a sample set of 10,000 samples. But here's the trick. These samples were already lying in freezers across the continent. So now we had scale, we could look at the variation in the response to malaria, and we could do it economically. So put those two innovations together, KillChip and SMART, and what you're looking at is the variation in the immune response to malaria in thousands of African samples. In rows are individual samples. In columns, those are the proteins. Bright red, that's a strong response. Bluish is a weaker response. That's just powerful. Interestingly, we found that responses from East Africa clustered separately from those from West Africa. My slides are jamming. There we go. So that's a principal component plot showing you that the clustering of samples from East and West Africa. But I bet you want to know what was your most important result. I bet you want to know which was the best protein, Faith. The answer was none. The effect size for any single protein, our best proteins, was disappointingly small at about 20%. What does that mean? It means if you take any one of our best proteins and you try to use that as a malaria vaccine, you would protect only 2 out of 10. So why am I excited? I'm really excited because when we add up these responses, we see efficacy increasing. From protecting 2 out of 10, this goes up to 8 out of 10, simply by adding in carefully selected proteins. And now you're looking at data from 1-year-olds who we really want to vaccinate. So our study now provides solid evidence for what we in the community have often speculated, even argued, but simply not had good data. We now know that one protein will not be sufficient. We will need a panel. We now also know which proteins to focus on for the next level of innovation that will see us create highly effective and universal vaccines. So science teaches us how to think logically, to innovate, and make data-driven decisions. I hope I have convinced you of that today. I come from a village in East Africa that no one's ever heard of, except those who live there. And how is it that I stand here today? I was fortunate to grow up healthy, protected from disease. I had the chance to learn in school. I trained in a fantastic environment where visionary leadership empowered me to drive my destiny. I believe that I represent what you are trying to achieve: equity. Equity in health, equity in education, in diversity, in gender. Ultimately, this leads to equity in innovation, giving the children of Africa a chance to realize their full potential, to be their own solutions. Now, I am president of the International Union of Immunological Societies, with over 60,000 members globally. I have launched a training program to provide opportunity for 1,000 solution-making African research trainees. To me, this is how we ensure a sustainable, disease-free Africa that outlives us. I welcome your support. And finally, in the words of history-making Kenyan marathon runner Kipchoge, no human is limited. Thank you.